In this video, I will show you how we generate plan and profile sheets using the design we created in the previous 4 videos. To get started, copy the template files from the templates folder. We are after the RVR sheets template.dwg, which is the sheets template, RVR styles template.dwt, which is the styles template, and RVR template ssm.dst, which is the sheet set manager template. Paste these into the templates folder in your project folder. In the Xref folder of the templates folder, copy phase clnt.eng.dwg. Paste this in the Xref folder of your project folder. Open the phase clnt.eng.dwg drawing. Information in this drawing will be Xref'd into all of your sheets. This will make it easier to make changes to the sheets after they have been created. We have placed a copy of the DST file in the main C3D folder of the project folder. Rename that DST so that it makes sense for your project. Now open the DST or Sheet Set Manager. Internally, rename the Sheet Set Manager by right-clicking the name of the Sheet Set Manager, then click Properties. Navigate to Name and adjust the name. Go ahead and close and save your drawing. In this case, the RVR sheets template.dwg will be the template for the sheets. Open that drawing. A pop-up will open regarding broken references. Click Open the External Reference Palette. Here we will fix the reference to the phase clnt.eng.dwg. Click the Save Path towards the bottom and correct the path's location. Each of the tabs in this drawing represents sheet or sheets in the plan set we are generating. This first tab is the cover sheet. The next tab represents the note sheet. Notice there are no scale bars or north arrows associated with this sheet. The Overview tab represents the Overview sheet, which has both a north arrow and a scale bar. The PP30SC tab represents the plan and profile sheets, which we will be discussing in this video. This sheet has both a north arrow and a scale bar and 2 view frames. One of those view frames will display the plan view, while the other the profile view. The SCCT20SC tab represents the cross-section sheets. It has a scale bar. The final tab in our sheets template drawing represents the details sheet. Like the note sheet, this sheet does not have a north arrow or scale bar. To get started, open a new drawing, one that is using the styles template. Point the data shortcuts at the project folder. Reference the data shortcuts into this drawing. The display order of these objects will be as they are brought in. You can save yourself work as you bring them in by adjusting the order for which you bring them in. The object you want to display on top should be brought in last. For this example, we bring in the existing ground surface, the design surface, offset alignments, the center line alignment, and its associated profiles. Bringing in the profiles, it is best to leave the profile label set to none. We have found it best to add those labels later in this process. With the drawing mostly set up, we can now create view frame groups. In the Prospector tab of your tool space, right-click View Frame Groups. Click Create View Frames. In the pop-up dialog, make sure that the correct centerline alignment is selected in the alignment dropdown. Here you can also select what stations you want in the plan and profile sheets. Click Next. On this tab, click the ellipsis and navigate to the template sheet drawing. Select the appropriate sheet. Click OK. There are a few more places that you can change how the view frames will be created. For this example, the default values are the values that will be used to create the view frames. Click Create View Frames to create the view frames. Now adjust the view frame positions and match line positions on the view frames. This is the opportunity to get the plan portion of the sheets looking the way they will be plotted. A little bit of time preparing the view frames in this step of the process will save you time down the road. Once the view frame groups have been adjusted, expand the view frame groups tree in the Prospector tab of your tool space. Click Create Sheets. This will bring up a pop-up dialog where we will create the plan and profile sheets. Most of the default values are what we want to use in this first window. These values may be different if you are using a different styles template. For this example, I'm going to change the layout name and the north arrow block. Click Next. Here you can direct what sheet set manager the sheets will be associated with. Click the ellipsis and navigate to the appropriate sheet set manager. Click Open. Now click Next. Here, select the Choose Settings radio button and click Profile View Wizard. Adjust the Profile View Datum By drop-down to mean elevation. Click Profile Display option on the left side of the dialog box. Scroll over and adjust the labels drop-down boxes. For this example, we will use label sets for both the Bankful and Thalweg profiles. Click Finish to close this dialog box. Click Create Sheets to cut the plan and profile sheets. Now save the drawing. Click on an empty space in your model space to create the profile views. The plan and profile sheets will also be created. You can move the sheets in the Sheet Set Manager by selecting them and dragging and dropping them into the appropriate subset. Delete the Layout tab that is no longer being used by right-clicking it and clicking Delete. Delete the subset that was created when we created the sheets. Investigate the sheets that were created to make sure they appear the way you intend them to appear. Go ahead and explode the dynamic north arrows on each of the sheets by clicking on them and typing X into the command line, then press Enter. I've had some problems with custom dynamic north arrows in plan and profile sheets in the past, and have found that exploding them helps me avoid some of those problems. Now we will add names to the sheets. In the Sheet Set Manager, right-click the first of the plan and profile sheets. Click Properties. Give the sheets appropriate names. In this template, we have 3 lines that can be attributed to the sheet name. For this example, we are using sheet line 2 to describe the type and chronological number of the sheet. And in sheet line 3, we are describing the stationing along the alignment that the sheet represents. Do this for each of the plan and profile sheets. Because some of the text overlaps on the bottom of the last profile, we are going to extend the profile view. In the model space, click on the profile view. Right-click and click on Profile View Properties. In the Stations tab, adjust the end station until the text no longer overlaps. Once it looks the way you want it, apply the changes and click OK to close the window. Now adjust the stationing name on the plan and profile sheet. Now we are going to adjust some of the dynamic fields in the title block. In the Sheet Set Manager, right-click the name of the sheet set. Click Properties. Here we will fill in the project name, phase, project 2, project location 1, and project location 2. All of the dynamic fields for the title block will be adjusted in this Properties window. Once complete, click OK. Now regenerate the sheet by typing REA in the command line. Press Enter. You will see that the dynamic fields have updated using the text you entered in the Properties window. Now relink the phase CLNT ENG drawing to the plan and profile sheets. Type Xref in the command line and press Enter. At the bottom of the window that pops up, you will see Saved Path. Click the ellipsis and navigate to the correct path for that drawing. You will notice a frame around the logo in the title block. To remove that frame, type Image Frame in the command line. Type 1, press Enter. Type Image Frame in the command line one more time now. Change the value back to 0. This will remove the image frame. Now we are going to add line work to the drawing. The line work is saved in a separate drawing that we will Xref into this one. Go to your Model Space tab, type Xref in the command line, and click the drop down on the first icon in the pop-up window. Select Attach DWG. Navigate to the line work drawing. Click the drawing, then click Open. In the next window, make sure that the path type is set to Relative Path, Scale and Insertion Point are set to Default, and the reference type is set to Overlay. Click OK. Close the window. To bring the labels back to the front, select the labels, right-click, select Display Order, click Bring to Front. Now we are going to add another Xref to the plan and profile sheets. This Xref will display the typical riffle and pool sections for the design. From one of the plan and profile sheets, type Xref into the command line. From the drop-down on the first icon, click Attach Drawing. Navigate to the Typical Sections drawing, click Open. From this window, make sure all the settings are correct. For this, we will click the Specify on Screen checkbox for the insertion point. Snap the Xref Typical Sections drawing to the midpoint of the top of the key map box as shown. With the Xref selected, type Copy Base into the command line. Type 0, 0, press Enter. Now delete the Xref. On the title block, type BE into the command line, press enter, click OK in the pop-up window. In the block editor, type paste clip into the command line, type 0, 0 and press enter. Close and save your edits in the block editor. The typical sections Xref will now populate throughout the plan and profile sheets. Now we are going to create a key map for the plan and profile sheets. Open a new drawing using the styles template. Bring the existing ground surface, the design surface, and the centerline alignment into the new drawing. Set the display settings on these elements as they come into the new drawing. If you are mindful about your preferred display order for the elements, you can once again bring them in based on that order. Data shortcut in the view frame group. This data shortcut was created from the plan and profile drawing. Set all of the styles, except for the view frame style, to no display. Click OK. Now go back to the plan and profile sheets. Select the key map box from the paper space. Copy that box to your clipboard by typing Ctrl+C. Go back to the key map drawing, go to the layout tab and paste the box in paper space by pressing Ctrl+V. Resize the view frame to the pasted box. Double click inside the view frame to enter model space. Unlock the box and type ZE into the command line. Click the scale at the bottom of the drawing. Click custom. We're going to create a custom 1 inch equals 400 foot scale to fit our map. Set the view frame to that scale. Click the polyline surrounding the view frame. Type CH space into the command line. Click enter. Go to the model space. Type base into the command line. Snap to the bottom left corner of the polyline. This will set the reference point for the drawing. In model space, type W block into the command line. Press enter. Select the entire drawing radio button. Click the ellipsis under destination. Navigate to where you want to save the drawing. For this example, the drawing is saved in the Xref folder. We do this to simplify the key map drawing, removing excess layers and styles from the drawing. Click Save, then click Yes to export the drawing. Close this drawing and do not save it. From the plan and profile sheets, type Xref into the command line and press enter. Click the drop down on the first icon from this window. Click Attach DWG. Navigate to the key map Xref. In this window, set the X and Y scales to 0.0025. Click OK. Now snap the Xref to the bottom left corner of the key map polyline. Type LA into the command line. On the left side of the layer manager, expand Xref. Now click key map. Shift click all but the view frame layer. Click freeze to freeze those layers. This will make it easier to draw in the key. Now draw a polyline around the first view frame in the key map. Pull up the properties of the polyline and adjust the global width of that polyline to 0.05. Select the polyline and the Xref key map and type copy base. Press enter. Type 0, 0, press enter again. Go to the next sheet, type paste clip into the command line, press enter. Type 0, 0, press enter. Now adjust the polyline to match the next view frame. Do this for each of the sheets. Once you are finished, don't forget to unfreeze the layers in the Xref. If you enjoyed this video, please like it. If you would like to see more videos, please subscribe to our channel. Thank you for watching. The next video in the series will be a walkthrough for creating section sheets.